We're going to simplify this expression. In order to simplify these expressions, we need to know what our properties of exponents are. So we have a few different properties when it comes to our exponents. The first one is our product rule. And what that says, if you are multiplying like bases, so if you look, the base of each of these exponents here is x, so we are multiplying the same bases. If you multiply like bases, the shortcut would be for you to add the exponents. So we have x to the third, we have an x, which is really like an x to the first power, and an x squared. So when you simplify that, you simply need to add up those exponents. When you're multiplying like bases, you add the exponents. So if you simplify that expression, you do get an x to the sixth power. For letter B, we're going to take a look at a fraction. And for this problem, we will use one of our other rules, which is our quotient rule. What a quotient rule says is if you're dividing like bases, you subtract the exponents. So taking a look at what we have in letter B, first of all, I do need to notice that there's no addition or subtraction in this problem. So what that means is we can go through and we can reduce the numbers, we can reduce each one of the variables that we have. And I would go through and do it in that order. I'm going to reduce the regular numbers first, and then I'm going to reduce the variables in alphabetical order. So first, we have 10 over 15. If you reduce the fraction 10/15, that would reduce down to a 2/3. Next, we have some x's on the top and the bottom, and if you're dividing like bases, you subtract the exponents. You can subtract two different ways. We could do the top minus the bottom, or the bottom minus the top. Either way, you will eventually get to the right answer, but if you want to do this a little more efficiently, it does make sense to go through and to do the larger exponent minus the smaller. The larger exponent this time is on the top of the fraction, so we have x to the 9th over x to the 8th. 9 minus 8 is 1. So we're going to have an x to the first power in this problem. We just need to decide where we want to put that, and the easiest thing to do is to always put your answer, if you do larger minus smaller, wherever the larger exponent was. So we have x to the 9th over x to the 8th. The 9 is bigger than the 8, so when I subtract those exponents, where I'm going to put that is up in the top, because the higher exponent was in the top. For our y values, we have y to the 5th over y. Remember, this is like a y to the first power. So again, I'm going to do the larger exponent minus the smaller, which is going to be a 5 minus 1. And the larger exponent, again, was in the top. So when I write this out, I am going to put the 5 minus 1 up in the top. This step, most people would just do in their head. Same thing with letter A. When we added these, this step right here is really unnecessary. This is something I'm doing to show some work, but you would be expected to go straight to the answer on that. Same thing with this one. Our final answer is going to have our 2/3, and then 9 minus 8 is 1, so we would have an x to the first power on the top, and then 5 minus 1 is 4, so we would have a y to the 4th. For letter C, we'll get into our third property. Here we have a power that's raised to another power, and when you have a power raised to another power, the shortcut, the property, says that we can multiply those exponents together. So our final answer for that is an x to the 14th. Let's talk about negative exponents for a minute. Our final answer should not have any negative exponents. If you look at what we did in those first three, we didn't have any negative exponents there. When you simplify, your answer should have positive exponents only. How you handle a negative exponent? All a negative exponent really means is that the base and the exponent are written in the wrong place, meaning either the numerator or the denominator. So what you want to do is think of this as a fraction. So in my first step, I would be thinking of this like 5 to the negative third over 1, and then how you get this exponent to be positive, how we change this negative 3 into a positive 3, is you take the base and the exponent that's here, and you move it either from the top to the bottom, like this one, or if the negative exponent were on the bottom, we'd be moving the base and the negative exponent from the bottom of the top to the top. When you move that, that is what will change the exponent into a positive. So down in the bottom we had a 1. We are now moving this 5 to the negative third from the top to the bottom, so it will become 5 to the positive third. There isn't anything left in the top. If there's nothing left in either the top or the bottom, there is a 1 that we can put in that place. So this ends up being 1 over 5 to the third, or 1 over 125. The properties of exponents that we have, they can be done in any order. So if you're applying more than one property, you can do the problem in more than one way. For this problem, let me go through and do it this way. We have right now a fraction that's being raised to the negative 2 power. So eventually we are going to have to handle that negative. But we do have a fraction inside of our parentheses. So our base this time is that 7/8 fraction. If you have more than one value with no addition or subtraction inside of parentheses like that being raised to a power, you can raise each of those parts on the inside to that power. So this is equal to 7 to the negative 2 over 8 to the negative 2 power. In order for us to do our next step, we're going to need to move the base and the exponent on both of these. So the 7 raised to the negative 2 power, we're going to move from the top to the bottom. That will make that negative 2 positive. Same thing with the base and the exponent from the bottom. So 7 to the negative 2 becomes 7 squared, and by moving it from the top to the bottom. 8 to the negative 2, that becomes 8 squared, moving that from the bottom to the top. That's going to give us 64 over 49 for our final answer. That's one way of handling that. Another way you can handle this exact same problem with your negative exponent is this. Your negative exponent, if you have individual numbers like we did here, can be changed from negative to positive by moving them. Otherwise, what you may notice is if you have a fraction raised to a negative exponent, and that fraction is in parentheses, your numerator, in this case the 7, when it was inside the parentheses with the negative exponent, got moved down to the bottom when we made the exponent positive. Same thing with the 8. Was on the bottom, when we made it positive, it went to the top. So one thing you can also do to get rid of a negative exponent if you have a fraction is you can essentially take the reciprocal. So if you flip that fraction over, that will give you 8/7 in parentheses squared. Both the top and the bottom are part of the base. So we get 64 over 49 for the answer that way too. So again, there's more than one way to apply these different properties. You just have to go through and apply them until you get down to your simplified answer. The work that we do might look different from person to person, but our final answer should be the same for everybody. For letter F, take a look at a negative 2 to the negative 4 power. And again, for this, we do have this negative exponent. So we're going to think of it like a fraction. It's not a fraction yet, so I'm just going to put it over 1. To take that -4 and make it a positive, I want to take the base and the exponent and move it. So the question becomes, what is the base of our -4 exponent? Does it include the negative symbol or not? And it doesn't. It feels like it should because we think of that number like a -2. But the base of the exponent is just the 2. If the negative were going to be part of the base, it would need to be in parentheses with the 2. So just like we did earlier when we were going through and doing some problems, when you have a negative with a number, the base is not including the negative unless that is in parentheses. So we had a 1 on the bottom. I'm going to take this 2 to the -4 power, and I'm going to move that to the bottom, making the exponent positive. What is left in the top is a negative with no number, so we can put a 1 up there in the top. So for our final answer, you would have a -1 over 1 times 2 to the 4th. 2 to the 4th is 16. So -1 over 16, or if you wanted to, you could bring that negative in front also. For letter G, we're going to do a 3x to the 7th times a -4x squared. If you look at this from left to right, we just have multiplication and powers. So you want to think of this like 3 times the -4 times x to the 7th times x squared. Multiplying our regular numbers together would give us a -12, and then x to the 7th times x squared. We add those exponents, so your final answer would be a -12 x to the 9th. For letter H, we're going to take a look at an 8 m to the 5th n to the 9th p to the 0 over a 12 m to the 15th n to the -2 p to the 3rd. So as you simplify this, there is a few things that you can go through and do. One of them would be to handle your negative exponents right away. So if you did that, you could take this n to the -2 power and move that up to the top. And then the other thing that we haven't talked about yet is this p to the 0. Any number to the 0 power is equal to 1, or any value, even a variable. So p to the 0 power, that is just equal to 1. So if we get rid of the negative exponents, we would have this. We would have an 8 m to the 5th, n to the 9th, and then moving the n squared to the top. And then we would have a times 1 out here on the end from that p to the 0 power. So we wouldn't even really need to write that down. Down in the bottom, we have a 12 left and an m to the 15th, and we have a p to the 3rd. So simplifying this out as best we can, regular division with regular numbers, we just want to reduce that fraction. 8/12 reduced down to 2/3. For our m values, we're dividing, so we're going to subtract those exponents. I'm going to do the larger minus the smaller so that I get a positive number, and the larger value is in the bottom of the fraction. So when I do the 15 minus 5, I'm going to have an m to the 10th, and I'm putting it in the bottom because that's where the base and the larger exponent was. Up in the top, I have some n's. Those n values that are there, n to the 9th, n to the 2nd power, we would add those exponents because we're multiplying those. And then we have a p to the 3rd, and there's not another value for p. And we have our 1 out there on the end. So that would be our final simplified answer on that one.